Hello, here at the AERO 2025 at the E-flight-expo second session, eVTOLs in different classes getting ready, part 103 ultralight, FAA part 23 and EASA SCVTOL. Welcome my guests here, and
I always try to bring you some new companies, not always the same, and that's why you see you will see it's from very different kinds also in the eVTOL world. And I think I have to be quick because we have a lot of speakers, so I pass my word to Pivotal. Pivotal was winning last year the E-flight-expo prize for their eVTOL, and I hand the mic to Alex to give us a latest update what they're doing. And by the way, you can fly the simulator of this aircraft at our booth here in A7100.
Thank you, Willi, and thank you for graciously accepting us as co-host at your booth this year. It's one of the reasons why we're here at AERO. Oops. So. Previously, we've spoken a lot about our electric aircraft, which is you see right here, which the current one that is flying is called Blackfly. And we've spoken a lot about the personal use case of having an ultralight aircraft that people can fly around with in the United States. Today, I'm going to talk a bit about the other potential use cases for our aircraft. And it's definitely one of the questions that we get asked a lot. What else can you do with Blackfly? Now Blackfly, just as a clarification, it's our pre-production version of the aircraft, and then Helix, which is a name we talk about a lot, is the production version of our aircraft. And in the videos, you'll see Blackfly flying. So this is a video that we made just to promote what we could do with our aircraft for emergency medical services.
911, what's your emergency?
Okay, so that was one of our use cases that I will talk about in a second. But in that use case, you see one of our customers who helped as part of the shoot as just a demonstrator of what we could do with our aircraft. And I'll talk exactly about that in a minute. I'll first talk about our go-to-market strategy. With that, we have a platform that combines a lot of different systems. We have our guidance, navigation control, we have energy storage, propulsion, we have our aircraft architecture, and all this works together in a platform that we can use across multiple different strategies. To go to market, our first aircraft will be the Helix personal aerial vehicle. But this platform will allow us to expand to multiple different use cases. We can have a variation of this, and then we can upscale it to other variations for different use cases. And finally, we have our services at Pivotal, which include flight training, mission development, maintenance and repair, and finally integration and engineering, all to support these different use cases. Now, we've spoken a lot about personal aircraft, of what our customers actually do. We've had a very successful early access program where we've had select customers fly our aircraft, own our aircraft, and we've trained them, and they've operated their aircraft, say, out in the wild, at their homes, at local airports. They brought our aircraft to different air shows, and that's really the personal aircraft perspective. We've also looked at defense missions and what we can do with our aircraft in these specific cases. And finally, we have public safety, which is the video that I just showed you of EMS emergency response. Now, one particular advantage of our aircraft, especially in the US, is that in the US, you don't actually need a pilot license or certificate to fly our aircraft. And the training is quite short. It can be like a 7-day or week-long training, and you can become a trained pilot of the aircraft. And I'll say this is particularly advantageous because you could have people who don't traditionally fly, such as paramedics or firefighters, actually use our aircraft for public safety missions when a helicopter is not available, or if a helicopter is too expensive for a certain jurisdiction. And one of the things that we've actually done is we've timed an ambulance and one of our aircraft getting a call and flying from one location to another to see which one would get there first. And I mean, our aircraft got there first, but just an example of what we can do. And going through these different things, like it's a learning lesson for us as well, since it is still in the early stages. There are challenges that we have to overcome, like how do you keep an aircraft operationally ready so that when a call does come in, how can you go from the call to jumping in the aircraft to taking off and going to your destination? So there's still operational challenges we need to overcome and think about, but this is one of the things, or one of the aspects that we'd like to use our aircraft for. So capabilities today that really help us with this mission is that it is quite easy to fly. Like I said, it only takes a week to learn on the aircraft, and a lot of the flight controls in the autopilot system, it takes away your traditional stick and rudder skills that you actually need to fly the aircraft. What's left for the pilot to do is really judgment and figuring out where they want to go. We do both crewed and uncrewed configurations, up to 220 pounds payload, and they're very quiet aircraft. With all these capabilities, we can work in logistics, a remote pilot extraction, search and rescue, first response, fire suppression, border security, and many different other applications. And I'll say there are many different types of platforms for aircraft, ranging from drones to combined thrust, with many different sizes in between. And our tilt aircraft body, I would say it's not suited for every mission, but there are very many missions and very many use cases that our architecture is suited for. And so I think we can play a very unique role in the public safety sector. Thank you.
Thank you. And one thing I can definitely say, because last autumn I had the opportunity to visit them, and I have flown the aircraft. So I've flown the simulator and I've flown the real aircraft, the first eVTOL I could fly myself. And after getting used to it, which took about 3 days in the simulator, in the end it was quite easy. Although before I thought it's very strange for a pilot to land on its back, but it works. The only thing I can say right now, we hand over, if you, our next speaker is going to talk about some case there is an overlap, which we mentioned with emergency response, and Alex mentioned there is some emergency response. And so David from ERC, he will now tell us of a German startup, and I'm very proud to have a German startup here with it actively working after there have been, everybody heard the difficulties of other companies around, and maybe we also have a surprising guest at the end here who can tell us a little bit of one of the famous names when we do the panel discussion, still have time. So David, the stage is yours.
Great. Thank you, Willi. And there is not only a small overlap, but a quite big one, which is in the end the mission about public safety missions. And definitely this is one future we want to build. We want to build the future of medical aviation. And this is nothing new. I just want to keep repeating it every time I'm presenting. We have a quite big cost problem in transporting patients. The reason is quite obvious. Although I love flying, flying is very expensive, especially compared to typical ground transport. But unfortunately, there's too many cases where actually ground transport is not sufficient, but we still do it because there is, no helicopter available, or you reserve the helicopter resources for the really critical cases. We believe that eVTOLs can be much cheaper, also new thesis, but not only in the power consumption, but especially in maintenance, and in the end the total cost of ownership will be much lower than a helicopter. And we definitely see there's a sweet spot between ground transport, cheap but slow, and flying with helicopters today, which is quite expensive. And our mission is really to solve the time-cost dilemma of transportation by building something that beats the helicopter in cost and that beats ground transport in time. Our approach might be a bit different to the approach of many of the other eVTOL players, and especially the first movers. For certain reasons, we focused on engineering in the first 4 years. We are now already 4.5 years old as ERC, but the first 3.5 years we really focused on building something big, something reasonable, and first proof that it's doable before shouting out what we want to do, and eventually not only show renderings but show really something flying. And we had a big advantage. Number one, the founding team of ERC already collected significant hands-on experience with another eVTOL company beforehand, where we built already a 600 kilogram electric aircraft, manned, flew with it, worked on 300 kilogram eVTOLs. And for this we were able to directly go full scale, full mass, and prove that we're not only building big model aircraft, but that we are really building serious aircraft. Also one enabler for this is definitely our major shareholder and investor, Professor Schwarz. I even do not want to call him investor, but he's really a very important person, some kind of founding investor. He has so much aviation experience, more than 50 years, and having such kind of strategic investor right from the beginning, knowing that aviation takes time and lots of money, helps a lot to not go the typical VC ways and over-promising to get more money, but in the end being able to focus for 3.5, now 4 years plus, to do something big. What have we done in the past? Just to give you some examples, already 2 to 3 years ago, we built something which we call flying hoverbed, and it already had 2.8 tons, 13 meters length. We played around a lot with motor inverter configurations, battery configurations, redundancy concepts. For an engineer, this is something very cool to play around, to learn, and to understand how to specify real product. For a non-engineer, it's rather something, well, what's that? And for this, we now have our second demonstrator that will fly very soon. Looks much more like an aircraft, much more mature, although it's still on demonstrator level. It's a real big aircraft, 3-ton takeoff mass. Again, we'll hover very soon, and then we will go towards the product. What was important and is still important for us is there is not this one vehicle fits all solution, and for this I'm happy to have Pivotal bring in the doctor there, and we come and bring the patient away. And just to give the example, and unfortunately for Lilium and Volocopter, I love both aircraft, but just to give you a comparison why there is the reason that there is many companies working on this topic. Volocopter, the perfect smart, short distance, bring something quite close and pick it up, but definitely not transporting a patient. Lilium Jet, I would have loved to fly with this one. For me, the coolest looking eVTOL at all, but so much complexity, much more expensive than many helicopters, and honestly there is not too much reason to use this one for flying patients. And we see ourselves as really the transporter of the air, which right from the beginning was specified together with HAMS operators to ensure that we can really perfectly fit in the niche, not the niche, in the sweet spot of having a medical transport vehicle at decent cost and with the right requirements. And for this, we did not only convince already many European HAMS operators, but right from the beginning, even before we founded EUC, there have been the first contacts with DRF, besides ADAC, the biggest German HAMS operator and one of the biggest one in Europe. And probably Florian Holzapfel can still remember when we sit together with DRF, I think 1 year before actually we founded EUC. And this also underlines that right from the beginning we tried to really solve the problem that is already there, this medical transport problem, and not try to build a vehicle and afterwards find use cases for this vehicle. And for us, still, we are convinced that this is the perfect entry for this kind of vehicle because the demand is there, the operators are already there, and for this, this is our way forward to go to this entry market for medical transport. And also there is not this one kind of EMS mission. You start with bringing the doctor to the scene, but it's so many different configurations, different from country to country and even different from local areas and countries and from, actually the situation of the HAMS systems in every different country. And for this, we try to really provide the solution that fits most of the HAMS customers that are, or HAMS operators that are out there, especially not only in Europe, but also talking to many in the US, to really understand what are the operators requiring for, what solves their problem. And in the end, this is why we believe we can become Europe's electric aviation platform, unfortunately for Lilium and Volocopter. But they prepared the way, and we now have to ensure that we continue this way and in the end deliver a product that can be useful for as many as possible and not just flying rich people from A to B.
Okay, thank you very much, David. And sorry that I make you to speak so fast, because I always tell them you have only short time because we want to have some time to discussion afterwards. So next speaker will be again back to United States. But Tom has been here in Europe and at AERO, I think, nearly as many times as myself. And he's been here at the E-flight-expo from the beginning. And he is working for a company now for quite a long time, but over the time he gave me a lot of different business cards because the company changed the name several times and also the ownership, but they are very persistent and I think they have a good backing now to be one of the companies who will reach the market at some end. So Tom, stage is yours.
Thank you, Willi. So at Wisk, our mission is to deliver safe everyday flight for everyone. To give you an idea of the aircraft, here are just a few key elements that are important to know about: conflict detection and resolution, airborne communications, avionics hardware and software, electric motors, energy storage. So you might ask about why conflict detection and resolution. Part of that is because there's no pilot in the cockpit. That's what makes our product and service unique. So we're focused on safety. That's always first, using the highest possible safety standard. Autonomous flight with human oversight, so we still have ground-based crew. A simplified design and no single point of failure. We've published our concept of operation. This is on our website. It is consistent with one that was developed by the FAA to describe these kinds of operations. They're quite different than the traditional operations you see today. So there's an airspace roadmap, development pillars, and validation approach. And here's a little video.
Here's how our self-flying system works, from the perspective of the aircraft, the multi-vehicle supervisor, and the passenger. Safe autonomous flight starts on the ground. Like all aircraft operations, we must ensure the air taxi is safe for flight before we take off. Unlike others, our aircraft autonomously performs the pre-flight inspection. Prior to flight and continuously throughout the flight, the autonomous system checks and monitors multiple aspects of the aircraft, from power, avionics, controls, motors, sensors, seat belts, and more. Inside the cabin, passengers prepare for flight. Safety briefings and instructions are provided via individual interactive displays, similar to those that you would expect to see on today's commercial airliners. This ensures the aircraft is ready for flight and passengers are informed and ready to take off. A critical component of autonomous flight is the multi-vehicle supervisor, who continuously monitors flights from our ground control station. Once the autonomous system has verified the aircraft and passengers are safe and ready, the supervisor is notified. As the final authority in the pre-flight process, the supervisor confirms the flight with air traffic control and initiates takeoff with a click of a button. In flight, the aircraft leverages proven existing technologies, like those used by commercial airliners. Through these enhanced capabilities, the aircraft can navigate, identify ground and airborne hazards, and adjust its flight path to maintain safe operation. Inside the cabin, passengers view their flight path in real time, allowing them to anticipate turns, climbs, descents, and transitions. The display also confirms the aircraft has recognized potential hazards and is taking corrective action. Real-time communication ensures passengers are informed throughout their flight. In our ground control station, the multi-vehicle supervisor continues to monitor the aircraft and the flight. If the aircraft takes steps to avoid potential hazards, the multi-vehicle supervisor is notified and may need to communicate the maneuver to air traffic control. For landing, the aircraft uses a combination of inputs from robust and redundant landing capabilities, such as precision navigation and onboard and ground-based sensors, to approach the landing area. The aircraft automatically confirms the landing zone is clear and begins its final descent to land. At the same time, cabin lighting, audio cues, and the interactive display notify passengers to prepare for landing. The multi-vehicle supervisor is made aware that the aircraft has started its approach and coordinates final clearances with ATC and the vertiport. Meanwhile, the autonomous system is also relaying information like the health of the aircraft, passenger arrival needs, charging status, and more. This combination of proven technology, proprietary software, and human oversight is making safe, self-flying, all-electric flight a reality. For more in-depth information on our 6th generation aircraft or our self-flying system, visit our website.
So where are we in the process? You just heard this was our 6th generation. We've been working on this through 5 previous generations for 14 years now. But we are in the final stretch here with the aircraft. So what you just saw will be flying this year. We are going through type certification with this product, so we have that already started with FAA. We're one of 2 companies in the US active with this kind of a system. We are also developing the ground systems. Since this will be a certified product, that'll be a different level than what we've had in the past. And we'll have to find some alternate means for qualifying the ground-based crew compared to an onboard crew. We'll also end up with a production certificate, so we're going through that process as well to get that set up with our quality system. And we'll also not only be the OEM, but the operator initially. So we're in process of getting a Part 135 operating certificate, and then we'll establish and demonstrate that we're capable as an airline to operate. So that's what it looks like on the inside. If you're in the front seat, there are no pilot controls. It's just like if anybody's been taken a Waymo ride in an autonomous taxi, very similar experience that way. So here's what it looks like on the ground with our different people who are involved with the operation. This talks a little bit about those qualifications that need to be considered for that ground-based crew. Of course, we're going to base as much as possible on the existing qualifications for pilots, but it'll have to be modified considering the aircraft will now do a number of operations that a pilot would have done in the past. The landing and takeoff for this aircraft, so we take off and land like a helicopter vertically, is something that requires some support beyond what we have today for heliports or vertiports. So we have a whole briefing on all of the elements that are unique to this aircraft and this type of aircraft. One of the things in particular is the automated systems and how they will integrate with the landing facility. And these are some of the things that need to be considered there. The size of the aircraft, 50-foot wingspan, 7,000 pounds. We want to be able to charge rapidly, so there's all of the power considerations on the ground. We have landing gear skids like a helicopter, and then getting folks on and off board. And that's all I've got. Thank you.
Thank you, Tom. And you see, there are some companies which are already flying, and some companies like Wisk, which is already flying, but until they get to service, it will probably take a while. Just one thing I want to, as we are talking quite a long time here, you're at a show. If you don't want to miss something, you have an appointment. We cover all the sessions with video. It's available on our YouTube channel. So even if you're an appointment, maybe you go, you come back and ask your questions. If you cannot stay, and you will have the information sometime later in the internet. And also, most of the companies we heard up to now, you find them in the A7 hall. So you can have a look, you can speak with the people afterwards, because sure, it will be only a short glimpse of what they're working on. Like we heard from Tom, when they are for more than 10 years working on vehicles, that there is a lot of things to discuss. Okay, our next speaker is Professor Florian Holzapfel from the TU Munich, and he's not developing one vehicle, but as we know us for a long time, the TU has been a spark plug like other universities, especially the TU Munich, for a lot of spin-offs, which then later started interesting eVTOL and other aviation vehicles. So Florian, let us know what you think about all the environment.
So today I'm not advertising a certain vehicle, and I'm very happy that we had two very successful companies here from the US who are already flying. And not selling a vehicle, I'm the one to complain about Europe today to enable others like ERC hopefully to fly. As I don't see my own screen, I always have to turn back. So if I move through the plot of my, now the remote control doesn't work, seems my own one. Should work if you just move the mouse to the presentation screen. Let me check. Okay, wait. If we go back to the first slide. Can you go back and then start the screen presentation? Okay, now it works. So basically, as a plot, we know that this eVTOL thing is very often called the third revolution in aerospace. And now I already start with the problem because, or not, that's not the problem yet. Now we already have a lot of these vehicles successfully flying. So China definitely wants to become the leader in this domain, and I'm pretty convinced that they will become the leader in this domain, because with their low altitude economy, basically they're pushing this domain like nobody else. But also, as we've already seen in the US, there is a lot of successful vehicles flying, and what we learned is that programs like Agility Prime, for example, are of course also a big public support to that. Whereas in Europe, of course, we have players, but we start to lag behind, and I want to analyze why that happens. And one of the problem was, and I don't know if the video will run, if not, it doesn't make too much problem. I took intentionally old videos from 2018, which in my opinion were suggesting something which is far off any reality. Because what we had in this time is that basically passenger transport in urban areas was sold as a prime application, which suggested that we have thousands of vehicles flying, that we have millions of flights every day, and this is something which in my opinion was never realistic. But the problem is that at any time you had realistic people, but nobody listened to those, because in that time you had all the hype people, and this of course mainly attracted investors from other domains like IT. If you have a computer program, you put it on the internet, in this case easily. It does not have anything like a production organization or anything like quality assurance in production, and this led to a wrong perception. And the setups then were mainly metropolitan setups, and there was a story that it would be really a means of mass transportation, which it is not, just like it's not a daily way of motion. And so, of course, given that, basically, we want to fly millions of flights over populated areas. If you don't want to have showers of eVTOLs because you cannot protect against them with an umbrella, the logical consequence of this would be very strict regulation. And this is, of course, what happened. So basically, if you are a regulator, you have to take a conservative approach, and you have to take for serious what the people are saying. And they say, okay, I'm flying with thousands of vehicles, millions of times a day in your inner cities. And then basically, if you take these predictions for serious, then you have to set up very high safety standards. And this is what happened in Europe with special condition VTOL. So if you take the most recent form, it defines basically the category enhanced. And this is to be applied if you have commercial operations, which means whenever you fly passengers for revenue, and if you fly over congested areas, basically, which means everything where you can get a revenue would be in this category enhanced. And this category enhanced means that in the end, you have very strict safety requirements where you treat air taxis just like a big airliner. Now again, we can wonder, is that stupid? No, from a regulator point of view, this is not stupid at all. But if you follow the predictions which the hyping companies put on the table, you had to do this. Now we all see there will not be millions of eVTOL flights every day, so maybe it's time to question that. And that brings us to the point, basically, to take a new step to regulation. So what happened in the past by treating them the same, they hired a lot of people from large aviation industry, and of course those people did not complain, because you get 200,000 euros or more a year for playing CTO from home office, and you start to do things which don't make sense for these small aircraft, right? So you treat those aircraft like an airliner. Small aircraft are built of carbon fiber, but no, you start to rivet, and basically you overwhelm everything by processes. I know a lot of general aviation companies. I did not see any general aviation company who has a requirement document that says requirement lift, and then has a compliance matrix that says satisfied by wing, right? So too much money was wasted, in my opinion, on processes, and the wrong tools, in my opinion, were applied, and this leads to burning amount of money which is unprecedented for general aviation, and which is not at all addressing the specific challenges you have in eVTOLs. We want to build eVTOLs. We do not want to build big and heavy processes. Manfred Müller was the former head of the flight safety research at Lufthansa, and I asked him to provide some of his slides so that we get a feeling about safety levels. So in hospitals, if you take surgery in a hospital, the probability you die in a complex surgery is 10 to the minus 2. The probability that you die on the ICU due to a treatment error is 10 to the minus 3. And now, very interestingly, if you go skiing, and if you take the statistics of how many skiing tickets are sold and how many people make it to the hospital with a really serious injury, not only a broken leg, then you see skiing is not very safe. And if we continue to look at flying, the worst thing you can do is the space shuttle, but air races and so on are also not very good. And if you look at this in a more qualified manner, then we see, here we are at a general aviation fair. general aviation is not really safe. We are in the order of magnitude of 10 to the minus 4 per flight hour. If we are looking basically at business aviation, we are in the order of magnitude of 10 to the minus 5, and even the IATA airline standard, which we really get today in daily operations, is something like 5 times 10 to the minus 7. So what can we take here now for our eVTOLs? So we have to make a paradigm shift, in my opinion. There is a lot of applications where eVTOLs do make sense, and we heard about the medical transport. But for the medical transport, it's getting people from remote areas to the hospital. So if we get people from remote areas, it means that most of the time we will fly over low population density area. And we will not fly somebody where the tooth is hurting, but we will fly somebody who has a serious medical issue, right? Where basically the risk, if we don't transport the people by air, is a high risk of life. And beyond that, basically, there is also other applications, like, for example, in the US, the e-stalls, where e-stalls and also eVTOLs do make sense, not for flying people from the gender compliance governance meeting to the caviar eating event, but if you have complex terrains where you have a lot of islands, where you have mountainous areas, there is a lot of good applications. And unfortunately, what we had in the past was blending out these applications because things were sold which are far off reality. And so what we have to do now is to take a proportionate approach. We have to say, okay, with eVTOL operation, we do not want to endanger anybody who is not involved. So we must not increase the ground risk for people who are not part of the system. And for the people on board the aircraft, we need to take proportionate measures, and we should orient these measures on the level of safety which we have today in general aviation. And so basically we can do this by not only looking at the vehicle, but also basically having an impact on the type of operation. How much time do you fly over populated areas? How many people do you carry? And if the fear is that the scaling up will let us lose control, you can also restrict basically by the volume of operation you allow. And basically this is something which, for example, is done in China. And one of the big lessons which I want to convey on the next slides is, currently everything commercial must be in category enhanced. Let's consider the category basic also for commercial applications. And this is very proportionate. I will not talk about the drones, but I just have one soda slide and I click through it because we are too many people. The point about this is that you check what is the risk to the people on the ground. And then basically the level of safety you have to achieve is proportionate. You have as risk on the people on the ground. And if 90% of your flight is in a rural area because you're taking people from a small village to a hospital, then you should not have to follow the rules like you would fly in a city all the time. So to get more specific, in our case, that would mean if we have a medical transport from a rural area and there is 2 people of crew, 1 doctor and 1 pilot, then only the patient is the passenger. And we are mainly flying over low density population density, and this would mean that we would end up in category basic 1, and this starts to be really proportionate. The same is, we want to fly a family to an island, right? So you fly to a place and then for holiday you want to go to the next island. Again, you fly most of the time over water. So it's a low population density and you're flying 4 people. Then already now taking category basic would be more proportionate. But now let's do, and this will be my main takeaway, for general aviation with fixed wing aircraft. Currently what is endorsed for the level of safety is the FAA Advisory Circular 23-1309, and we can directly compare that to the eVTOLs. So why don't we downgrade the certification requirements of the eVTOLs to exactly the same, which is now the valid regulation basically for manned aircraft? Because by that we could significantly lower the entry price ticket and we could make eVTOLs happen also in Europe. What currently happens is that with the type of regulation we have here, things are so expensive that it takes more than €1 billion to enter the market, whereas in other regions of the world, they are not sacrificing safety, but in other regions of the world, people have pragmatic and proportionate approaches. So basically, my conclusion at this point is eVTOLs will never replace the helicopter. This is another statement because we have a lot of opposition from helicopter people who want to save the system. The helicopters will stay. And for example, if we suppress applications like medical transport, we are not making things safer, we are actively killing people because we are not giving them the best transport they can get. And in the end, basically, if the whole aviation would have started with the requirements which we have today for passenger aviation, we would have no airplanes today. So if you introduce a new technology, you have to start at a lower level, otherwise you will never be successful. And the German philosophy very often is flying is safest if you don't fly, so if you inhibit the flights, then you have a high level of safety. And so the best guess I can give is let's accept category basic also for commercial operations. And so there is a lot of things where Europe has been strong, but very honestly, what I'm really bothered is that very often we are talking very arrogant about, for example, what people are doing in China. If you travel there and have a look, you will see it's very intelligent people with very good technological skills. And maybe it's the time now where we have to realize that instead of being arrogant and saying that we are so much safer, we should have a look at what others are doing and why they're doing it, and maybe the time has come where we can learn something from others. Thank you.
Thank you for your very enthusiastic talk. I think there's a lot of people thinking in this direction here, but you pointed out very clearly, and I think maybe we should have had several people from EASA and even politicians here for maybe changing the rules, and that it not takes another 10 years for changing the rules, because then there probably will not be any or very little industry in this area. But in Europe. Now I come to another European player from Czech Republic. We haven't had eVTOL from Czech Republic. We have had you here several years exhibiting, but I really thought it's time to bring you also on the stage with your development you're doing over there. And he's taking one point, which is, I think, very important, that flying with battery only, nowadays battery technology, eVTOL, especially when you want to do regional services, probably will not work. So let's hear from you, Mikaël, what your Zuri aircraft is doing. Presenter. Just
thank you.
Green button.
Okay, so I'm Michal from Zuri. We are building a vertical takeoff aircraft. This one is for passenger travel. Hopefully we will solve a lot of problems with current transportation. eVTOLs don't need airport, they can basically take off and land anywhere. They are much more cheaper to operate and quieter compared to helicopters, and they are not stopped by the ground traffic. Our aircraft looks like this. We believe in tilt rotors, so all of the 8 propellers that you see are tiltable between the horizontal and vertical position. And this is how we ensure the optimal flight characteristics throughout the whole flight. There is no dead weight, everything is working all the time. And there is also sufficient redundancy to reach the high safety levels that are required. We target 700 kilometers range, and I will explain how it is possible to do it in a minute. We have a large-scale demonstrator. This aircraft flew for the first time like 3 years ago. It's an 11-meter wingspan aircraft, so quite similar to the final size. And we are testing a lot of subscale models as well. Like we spent the whole winter flying like 2 times or 3 times per week with the smaller models, and this is where we test the transition. Like that's the difficult part between the vertical takeoff mode, that is transition when we tilt all the rotors and then fly forward. Our main use case is passenger transport, so single pilot and 4 passengers. But the same aircraft can be used also as a heavy cargo airplane. It's not different airplane, it's just another interior configuration, so you take out the seats, and then you have quite a generous space for standardized Europalettes. And the third use case is actually the one that you heard a lot about today. It's some kind of medevac or search and rescue. Again, in our case, not a different aircraft, but another interior configuration, this time for a lying patient and medical personnel. What's different about Zuri compared to companies like Joby, Archer, or recently with Lilium in Germany is the range of the aircraft. So we are not battery only powered, because that basically brings only 100 kilometers of range with a mandatory reserve. We can do 7 times more. And that is because we are a hybrid. So inside the aircraft, there's not only batteries, but also a classical turbo generator, the one that is already working for decades in helicopters. And this turboshaft engine is coupled with a generator producing the energy for a whole flight. And this allows us to pack much more energy in the same amount of weight compared to even the best batteries today. On the map, it looks like this. The small circles is what is achievable with battery-only eVTOL. The large one is hybrid range. Some people believe that batteries will get better in time, and that soon it will be possible to fly on batteries alone. It's not really the case. With the current growth that we see in the market, it is something like 15% improvement in the specific energy every 5 years. So it will still take like 30, 40 more years before the batteries even partially catch up. eVTOLs of this time are also quite quiet. This is a slide from a competitor called Joby, but it applies to Zuri as well, because our technical parameters like the disk loading are quite similar. And you can see that the well-designed eVTOL is orders of magnitude quieter compared to both classical helicopters and airplanes. This is how the interior will look like. And one of my previous speakers mentioned the high costs for certifying or building the eVTOL. It is getting a little bit crazy, like the American companies or even Lilium in Germany spent billion of development money, and we basically can achieve the same milestone with significantly less money, because we are based in Czech Republic. One more important thing is the sustainability of this project. And surprisingly, Zuri with its hybrid approach has really low emissions. That might seem counterintuitive to many of you, but when you run a turbogenerator on sustainable aviation fuel, the emissions are really low. It has already like 80% less emissions compared to regular jet fuel, and combined with other advantages, it brings us on the similar level with electric cars or trains. So using the sustainable aviation fuel already produce 2 times less emissions in CO2 equivalent compared to electricity that you are taking from the grid to recharge anything. There are some smaller reasons, such as smaller batteries and having longer flights, which also contribute to this low sustainability. And that's it. So to summarize, we can fly 7 times larger distances compared to battery-only eVTOLs, and it is quite cheap to purchase and operate. Thank you.
Hello, thank you very much. And
Really, I was surprised last year when I got into the detail how far you already got, because we saw you were at the AERO, and it was not a very fancy booth with a lot of artificial designs and mock-ups, but you've done a lot of work, and I think there are some real good arguments for your kind of aircraft. And we now, before I come to our last speaker today, we've had designers or companies designing different aircraft. We've had the university, we've had an eVTOL with hybrid, and now Michael from Unither, he will give us an impression of an operator who really wants to use eVTOL and what they are doing for getting eVTOL vertical flying into the air, because they have a special use case. They want to use it, and that's why they're investing there.
Thank you, Willi. So my presentation will focus on the use case and a project-specific progress that was made last week in Montreal area in Canada. So this presentation will focus on project praticity. Praticity is a word in biology that basically refers to the electrical current generated by a flow of protons, so cool name. The same principle is at the heart of how hydrogen PEM fuel cells are actually used on our hydrogen hybrid flight test bed using a Robinson airframe. I will explain a bit more about this project in the next few slides. This project is a collaboration with manufacturer Robinson Helicopter Company. So to Willi's point, the use case that is driving our involvement in VTOL and electric VTOL technology is really basically what our parent company, United Therapeutics, is developing regarding advanced biotechnology that are hopefully one day going to create an unlimited supply of transplantable organs. So basically we're on good course to do that. On this picture we see the world's first designated pathogen-free facility that hosts those genetically modified piglets that are basically donor animals. So we plan to fly our VTOL aircraft and a hydrogen-powered helicopter from those facilities to 100 transplant centers, East Coast, US mainly. So United Therapeutics is a publicly traded biotechnology company. We're the first company to adopt that legal form. Basically our public benefit purpose is really focused on developing both novel pharmaceutical therapies and technologies that will expand the availability of those transplantable organs and organ alternatives. So addressing this purpose, we are also operating with an eye toward corporate responsibility, and that includes environmental sustainability. We recognize that the transportation of organs today is highly carbon intensive. So we're talking about small organ care system or cooler devices that are put on Learjet that are heavy on jet fuel. So our vision is to get rid of that and using sustainable aviation solution to serve the network. This map on the slide right now shows our 2024 ex vivo lung perfusion services flights over the past 12 months. As you can see, that's quite a large carbon footprint. So this is why we decided to create a fleet of zero carbon organ delivery aircraft as it pertains to its flight op. So this is a kind of our technology portfolio. So we've invested and we've also taken over some in-house development activities as well. So we have a collaboration with Beta Technologies, great progress there for both a conventional takeoff and landing all-electric flight, as well as good progress for the VTOL variant, the Illich 250, bottom right. We've also spent some time developing concept of operation for the last mile delivery portion of our organ delivery missions using smaller UAS or RPAS, remotely piloted aircraft system. My team back in 2021 did the world's first long delivery for transplant in Toronto between the donor hospital and the transplant hospital. On top of that, we've also developed electric propulsion system using helicopter airframes, denoted by the top right picture here. Really started in 2016 with some demonstration flight using 100% electrical powertrain, using a Bramo battery pack on this picture and the initially a EASA motor to demonstrate feasibility of all-electric VTOL flight, which, as we all know, is quite intensive in terms of the duty cycle on the battery. So made a lot of learnings there, on top of the last mile delivery solution that I've already talked about. More recently, in 2022, we did the world's first cross-country all-electric helicopter flight, Coachella Palm Spring, with 2 pilots on board, including a payload that basically was representative of our organ care system that has to be carried all the way to the transplant centers. So we discovered a lot about battery technologies, their limitation, and also the life cycle, right? So for VTOL application, all the data we've acquired over the last 9-10 years, following the technology evolution on the battery side of things, led us to consider now the hybridization of the power system. To limit those downside as it pertains to a 100% battery electric powertrain design. So we started to investigate what would it take to come up with a comprehensive hybrid parallel fuel cell plus booster battery pack design, specifically in the context of VTOL missions. We basically ended up on a hybrid parallel system that has a promising performance figure in terms of the achievable range using a liquid hydrogen storage tank system. So we believe that with the traditional helicopter, within the existing weight and balance and maximum takeoff weight limit, we can flicker the mark of 200 nautical miles with 500-pound payload using a traditional helicopter airframe and converting it to hydrogen electric hybrid parallel. So my team at Unither Bioelectronics, this is our R&D unit in Montreal area, Canada, started to investigate that and started to integrate the system into an actual proof of concept vehicle while looking at hydrogen safety. A few words here about hydrogen safety. For gaseous, I think it has been demonstrated, well demonstrated by companies like Toyota, so that's the bullet penetration test from the Toyota Mirai. That's a publicly available video, no ignition, no explosion of the hydrogen whatsoever. In terms of crash worthiness and post-crash survivability, this is a controlled experiment performed by Dr. Swain, comparing a hydrogen ignition fire and a gasoline fire. So we can see that the radiated heat is much more intensive for gasoline rather than hydrogen, which is much more directional. And actually on the left there was only a plus 13 Fahrenheit increase in temperature on the rear window, which is a good thing. Now there are also downsides on hydrogen that we're working through, but we think that it can be made as safe as jet fuel or avgas at the end of the day. So our first proof of concept vertical hydrogen flight use currently a traditional Type 4 H2 tank with structural straps mounted under the tail boom of the helicopter. Later this year we will swap that tank to a liquid hydrogen tank that will allow us to put much more energy in the same volume or in the same available volume. So that's the tank. We have a 36% storage efficiency, structural storage efficiency. We have composite vacuum insulated lines that basically are resulting in a very low boil-off rate while refueling, for example, given the lower thermal mass. So we're very excited about this project. Now a few words about helicopter history. I'm a big helicopter fan, as well as eVTOL. right? we're not excluding that, but in the helicopter or vertical flight history, that picture here is probably one of the most well-known picture, the first flight of the first practical helicopter, main rotor, tail rotor configuration, performed by Igor Sikorsky in 1939. Later, Frank Piasecki, the father of my good friend John Piasecki, first tandem rotor helicopter, 1945. And then in Quebec, last March 27th, that's the first hydrogen-powered helicopter flight performed by my team and piloted by my good friend Rick Webb, that also piloted previously the all-electric, all-battery electric demonstrator in California. So we're using this vehicle as a flying testbed. It's definitely not a conforming vehicle. It's a vehicle that is used as a testbed to inform a conforming vehicle that will use the R66 airframe. This is the R44. So I will play a short video here showing basically the very stable high voltage bus, top right, the motor torque, as well as the fuel cell power. So we have two fuel cell stacks that currently on the screen are generating 80 and 79 kilowatt, respectively, with a small booster battery pack that is used really just to level up the transient power demand or when there is a sudden torque increase on the system. So noteworthy, this flight was almost 90% plus. Hover is very tough. Just if I backtrack a bit, hover is very tough from a thermal management perspective, a lot of heat to extract from the system. So this demonstration flight, 3 minutes, 16 seconds, showed a very, very stable thermal stability on the fuel cell, on the motor, on the battery, etc., etc. So that flight really demonstrated that it can be achieved. Of course, it's not optimal. It uses low temperature PEM fuel cells. There's a lot of work to be done in terms of volumetric power density on the balance of plant component, but we believe that in the next 3 to 5 years, we can reach a very, very interesting volumetric power density as well as a gravimetric power density on the fuel cell specific system. So just to wrap up, I know my time is running out here. Key takeaways as it pertains to hydrogen for VTOL application. I think it is well summarized in that PEM fuel cell model NASA contractor report paper, Professor Data from the Afairs Rotorcraft Research Center. Basically, there are two main factors that needs to improve to get a functional, viable VTOL aircraft. Number one is the tank storage system efficiency, right? So 15% plus. With our technology, we are 2x that at the moment, and it works very well in the lab. And the ground tests regarding the permeation and the roll-off rate, which is less than 1% per day. So we think that it starts to make sense with that lightweight liquid hydrogen tank storage. And the second aspect is the fuel cell stack net power density. So the threshold really to make VTOL viable is 1.1 net kilowatt per kg. And we see on this chart that a lot of people are going to hit that mark in the next 5 years. This is obviously not the net specific power. So the net specific power is the total specific power less the power required to feed the balance of plant components, so compressors, etc. But we are very, very excited, and I think about that, and I think that the promise or the upside potential of the technology improvement for fuel cell and hydrogen, liquid hydrogen tank storage is obviously a winner on the long run. So I will end my presentation just with a short 60-minute sizzle if we have time. First flight.
Yeah, sure, yeah.
60 seconds, okay, okay.
Because then we have,
okay,
yes.
this is just the beginning of
the
something.
first flight is definitely something.
Okay. that completes my presentation. Thank you for your attention. This is just the beginning of range demonstration, upcoming and flight test envelope expansion with the liquid hydrogen.
Thank you very much, and I sure understand, I think most of us will do here, because if you work on a project like this and then you have a first flight which is successful, everybody around the stage will see that this is really something you want to share, and I think we also want to share it with the people to see that yes, it's moving, because very often the people come to us and they say, hey, will electric drive really happen because you're here already for 20 years, and yes, it is, and we see seeing the first certified aircraft from China flying today here, having the eVTOL being on sale, you can buy it, you can fly it, having the first vertical flight with hydrogen. So yes, it is moving, but it's a little bit like always in aviation, a little bit slower than you hope it will moving. So I think we have about 4 minutes for questions. I would have a lot of questions, but if some of you in the audience has a question, just raise your hand. While this, I would ask first question to the last presenter, to Michael. What about, why using the fuel cell now in a helicopter and not in an eVTOL? Because
that's a good question. I would encourage all my eVTOL friends to consider fuel cell technology for their eVTOL. But the use of a helicopter is a strategic for us. We have a philosophy in technology development where we have multiple shots on same goal, and using an already type certified airframe and modifying it and processing the modification under a supplemental type certification is a lower certification risk. Of course, a helicopter doesn't have the L over D that a fully optimized aircraft could have, like in the eVTOL era. But in terms of certification risk and the entry to service, we think that it makes sense. And now with the hybridization of the system and the promises of the fuel cell improvement in the next 3 to 5 years, I think it makes a very appealing product, a zero-emission VTOL product.
So just as add-on question, so you think when the system once is running and you would have by the same time certified the beta, let's say, in a version, either vertical lift or the CTOL version, then the system may be ready also to be integrated in such kind of aircraft?
I think that technology could be adapted to many types of aircraft. Yes, absolutely.
Okay, so we have a mic in the audience, so if you want to have a question, lift your hand. I don't see a question there. We have still some time, because the next session, I will stay here just for those people who are waiting. We will have our next session on e-Commuters, which will start in about 3 minutes from now. Question to the ERC, to David. Did you consider with your aircraft also to do hybrid? And if hybrid, maybe fuel cell, maybe rather before doing another power source?
So I love hydrogen, and also love to see the demonstration, but I'm still a bit concerned about certification of hydrogen. Already certifying an electric aircraft is hard enough. Certifying hydrogen plus eVTOL would be maybe too much, at least in the times frame we're looking into. Of course, hybrid is a quite important point. The ranges we can achieve with purely battery electric, we have heard it from Zuri, might not be sufficient, although honestly for most of the missions, especially in the HAMS and medical transport business, for most of the missions it would be sufficient, but just operators are still a bit anxious and would love to see more range. So definitely something we consider, we look into, but no decision yet.
Okay, so last question I would like to have to Florian. As you have seen a lot of eVTOLs, people coming, I know several people in several companies come out of your university. What do you think of hydrogen? Do you think hydrogen will be a factor relatively soon in the eVTOL or electric flight industry, or you rather think no, it will be battery electric and maybe in 10 years hydrogen?
I put it like this: for the time being, there is not a single certified eVTOL flying in Europe, and I think you should always take one step at a time. And so, of course, to certify the first vehicle, it makes sense to stay purely electric, but I think there is no discussion that it will take a long time until batteries reach a certain level of energy density, which means if you want to go higher ranges, hybridization does make sense, but I would fully support what you're saying. You have the hybrid technology. This one you test, implement and certify in a already fully certified airplane as a STC, be it hydrogen or be it carbon-based F-gas or a diesel with a generator. And on the other hand side, you certify the eVTOL, so you master that technology, and then the step to bring the two worlds together basically is not a big one, but we should do one step at a time and not aim for something which we will never reach.
Okay, thank you very much. I think we have to close here. We don't have too much time to discuss unless one of you here on the podium has a question to one of the others. Then I would leave this time for the question. Otherwise, thank you very much for being here, for giving us this glimpse of a view what you're doing. I could stay 2-3 days and listen to everybody of you for a longer time. And what we will do is, we have the magazine here, which I'm doing, where we publish about a lot of the aircraft, a lot of things we heard about here. And so you can download this for free. There is a QR code on which you see which you can get. We have our booth over there. So come by and you can discuss with us later in the evening as well. Thank you very much. Thank you for being here.
You want to know more about electric flying and eVTOL? Just go to your browser, type e-flight-journal.com, click enter, and you arrive at our blog site of E-Flight Journal with all the latest news on electric and eVTOL flying around the world. If you want to read the PDF or printed version of the latest E-Flight Journal, click on the button next to the image on top. You arrive on a site where you see the latest version. You can flip through the pages in small or enlarge, and then you can read it on the screen on your cell phone or tablet, wherever you want. If you want to read the magazine offline, click on the link below the image. You arrive on our Yumpu reader site, where you can either then flip through the pages again and read the magazine, or download the paper. You can save it anywhere on your computer or cell phone and then read it whenever and wherever you want. If you want to read another issue of E-Flight Journal, just scroll down on the Yumpu site and you will see the older issues of the magazine. Just click on it. After you clicked on it, you can then download this other magazine or immediately read it in the reader again. Just flip through the pages and enjoy all the news on electric flying, from flight reports to government information and technical information on all details. If you like it, subscribe the magazine and you will receive the updates on a regular basis. Thanks and goodbye.